All right, to recap, in substitution, I combined using the method of substitution the two equations with two variables into one equation with one variable. Elimination is going to do the same thing, and I said that when I added those together, so elimination, another way to call it or say it is combining it. I'm combining the two equations, so I'm adding them together. And when I add them, I want to eliminate, so elimination, one of the variables. Right now, none of them eliminate. So there's an extra step I have to do. Okay, and what I need to do is I need to multiply either one or both equations by something that will eliminate. So once I multiply, it'll eliminate one of the variables. So let me do it and I think you'll see what I mean. Oh, it's okay. Yeah. Oh my. Oh my goodness. She didn't like that. Okay, so I'm going to multiply all of the bottom by 2. So I'm going to keep the top 2x plus y equals -5. On the bottom, everything gets multiplied by this 2. Okay, so I'm not changing the value of the equation when I multiply it all by the same number. So -2x plus 6y equals 12. So now when I add them together, the x's cancel. 2x minus 2x is 0. Y plus 6y is 7y. And then I have -5 plus 12 gives me 7. So you notice, I'm going to put a little bubble around there, that the 2x and the -2x canceled. I could have chosen to cancel the y's, and if I had done that, I would have multiplied all the top by a -3. So -3y plus 3y cancel. So essentially multiply one or both of your equations by whatever number is going to essentially make opposites, right? So 2 and -2. Once I have that, again, I'm going to add them together, okay, and I'm going to solve. So 7y equals 7, y equals 1. Ta-da, we knew that, okay? And again, if I want to find the value of x, I would plug it into one of the equations, and we already did that before, so my answer is -3, 1. So, recap. When I'm solving a system of equations, I'm solving for more than one equation system. It's a linear system, and when I'm solving, I want to know where do those two lines intersect. They can intersect once, so think if I have two pencils, they're only, no matter what happens, so I can even use my two fingers, they're only going to intersect one time. They never intersect, or they're touching. They're going to intersect always, okay? And to find that intersection point, I'm going to graph them, see what happens, check my answer, use substitution or elimination. In this case, it seemed like substitution might have been the easiest, but they all seemed relatively the same. But you'll notice as you go through these that sometimes there's going to be one method that definitely stands out as being the easiest. So for example, for elimination, if I can see that the x's already cancel when I add or the y's already cancel when I add, use that. With substitution, if you already see that one of the variables is already isolated, use that. And graph and check is always a great way to just double check, especially if you have something like no solution or infinite solutions. It's just a great way to double check that you're correct if you get something like super funky. Speaking about things that are super funky, let's say that I solve these. So I'm going to do a different color. I solve these using algebra, so substitution or elimination. If you get something like -5 equals 10, then that would be no solutions. If you ended up with something at the end like -5 equals -5, then that means it's all solutions infinite, okay? So that would be your key. And again, you might want to graph it to double check. All right, so I hope that helped, and I will see you later. Bye.